And then another type of loose connective tissue is reticular connective tissue. And this one really gets its name. I'm going to try to write on this board, but I don't know if y'all will be able to see it on your screen. So we'll give this a shot. Does that show up on your screen? I don't think so. What I just underlined up here, can you see any of that?
No, ma'am.
Oh, okay. Well, darn. Okay, I'll just write on the monitor. Thank you. All right, so reticular connective tissue gets its name because of the type of fiber that we have. And so it has, remember we have collagen, elastic, and reticular fibers. So this one gets its name because it has a lot of reticular fibers. These are fibers that are similar to collagen fibers. Remember, collagen are the ones that are stronger than steel. So these are kind of similar to collagen fibers. They're a little more delicate. Okay? They're not quite as tough as collagen. And remember, when we're dealing with a connective tissue proper, it's always going to be a type of cell called a fibroblast. And so a lot of times we have fibroblasts in our reticular connective tissue, but sometimes we just call them reticular cells. I'll call them fibroblasts. The only time I'll differ from when we're doing a connective tissue proper, the only time I'll call it the cell something different from fibroblast is when we talk about adipose tissue. That's when I call them adipose sites. Okay. All the other connective tissue propers are just fibroblasts. Just makes it easier. So where do we find this reticular connective tissue? We're going to find it in organs that sort of have like a soft internal skeleton. They have to have a lot of structure. So some great examples are things like the spleen, even in your bone marrow. Your bone marrow, remember, is found inside your bones, inside the hollow spaces of your bones. And that has a lot of loose connective tissue, this reticular connective tissue in it. So here's a picture. This is of the spleen. And so you can see in black, these sort of black strings that are thick. Those are reticular fibers. And then you can see those fibroblasts. You can see the fibroblast nuclei. You can also see some white blood cells in there. So I'm going to skip back and just walk through a couple of these tissues that we did already, just to show you the difference between a reticular fiber. And let's go back to this one. These real skinny black ones here, remember, those are elastic fibers. So if they look like a piece of hair, it's an elastic fiber. If it's thicker and really dark, like these, it's reticular fibers. Okay. So those are our loose connective tissue propers. We also have dense connective tissue proper. Thought I could do that. Let's see. Hang on. I got to get that off the board. It's driving me nuts. Okay. So dense connective tissue proper is when the connective tissue is really dense and jam-packed in there. So we have two kinds. We have dense regular and dense irregular. So the term here that we're looking at is regular. So this is a tissue that's very compact, and all of the fibers in this dense regular connective tissue are very parallel. So they're regularly arranged. And dense regular connective tissue has a ton of collagen fibers in it. And so collagen fibers, remember, these are the ones that are stronger than steel. They're usually thick and they're usually pink in color. And so because they're really, really tough, they can withstand a lot of tension. But again, think about this. We're looking at fibers that are all running in the same direction. So the tension that this tissue can withstand is from one direction, being pulled in one direction. Again, we're still looking at connective tissue proper, so we still have fibroblasts. And where we find dense, regular connective tissue is going to be in things like tendons and ligaments. Again, if you think of a tendon, it's being pulled in one direction as that muscle contracts and pulls on the bone. So here's a great example, right? So we're looking here at some ligaments and tendons. And so you can see like this tendon right here. Ooh, I don't know what happened to that. Okay, and see that tendon right there? It is going to withstand tension in just that one direction as it's being pulled. And if we look at this fiber, the fibers in this tissue, notice how they're all in this one direction. So this is why we call it dense, regular connective tissue. All the fibers are running in the same direction. It's nice and pretty. They're all parallel. You can see those fibroblasts, the nuclei in there as well. And then the other kind of dense connective tissue is dense irregular. And this one gets its name because the fibers are irregularly arranged. They're arranged almost in like a hodgepodge. So they're kind of all over the place, running in different directions. Still collagen fibers, so they're still stronger than steel. They're really tough. But now think about it. You've got collagen fibers running in all different directions. So now you have a tissue that can withstand tension from lots of different directions. So where we find this is going to be in places like in your skin, not the top layer of your skin. The top layer is epithelial tissue, but just under that layer is called the dermis. And the dermis has some dense, irregular connective tissue in it so that it can withstand tension from lots of directions. Think about your skin and how often it's getting pulled in different directions, not just from moving and bending, but even from growth, from weight gain, from pregnancy. Your skin is being stretched in different directions. So this is a tissue that is really tough, can withstand tension from lots of directions, but it's not foolproof. It can tear. If you put too much tension on this tissue too quickly, it'll tear. And we see this in our body as stretch marks, right? And think about what causes stretch marks. It's going to be things like growth spurts, when you hit a really fast growth spurt, or pregnancy. You know, some women, when they get pregnant, I have a friend who gained 100 pounds when she was pregnant. And 100 pounds in 9 months is a lot of weight to gain. So you're going to get those stretch marks, which shows that tearing. So this is an example. This is actually, this is not part of the skin here. This is not the dermis. This is showing you dense irregular in a joint capsule. And so again, if you think about the capsules around your joints, they also have to withstand tension from lots of directions. And if you look at this tissue, first you're going to notice it's collagen fibers, right? Because they are thick and pink in color. And that's usually what we find. And then when you see these collagen fibers, they're not nice and regularly arranged. They are in a hodgepodge. So they're kind of all over the place. And you can also see those nuclei from the fibroblasts in there. All right, so if we just kind of flip between this one, dense irregular, and there's dense regular, you should be able to very quickly see the difference between those two. One is regularly arranged, nice and parallel, and one looks more messy, looks like a hodgepodge. Okay, so those are our types of connective tissue proper. So again, remember, we have our loose connective tissue proper and our dense connective tissue proper. Okay. Now another kind of connective tissue, so remember we have connective tissue proper, cartilage, bone, and blood. So another kind of connective tissue is cartilage. And we have lots of different kinds of cartilage, 3 different kinds. Cartilage is sort of in between connective tissue, like a dense connective tissue, and bone. So it's really tough, like a dense connective tissue, but it's just not quite as hard as bone. So it's sort of in between the two. Cartilage does not have any nerves, and it does not have a blood supply. Remember, A means not, so it is not vascular. So it's really important for cartilage, if it has no blood supply, remember it still has cells in there. The cells have to get nutrients. So it's really important that cartilage is getting a good blood supply and nutrients from surrounding tissues. So we actually have tissue that surrounds your cartilage that feeds it and makes sure that it gets some nutrients. There is a lot of fluid in your cartilage, and that's really important because the extra fluid in cartilage helps your cartilage rebound once it's been compressed. So think of like the meniscus in the knee, right? It has a lot of fluid in there so that as you're running and jumping, it is getting compressed, but it'll rebound. Now remember, the type of cells that are in cartilage are chondroblasts, if they're immature, and chondrocytes, if they're mature. So remember, when we're talking about connective tissues, I mentioned this on Monday, it always typically, except blood, follows the blast site rule. We have an immature cell, and then once they've created the tissue, they become the mature cell, the site. Now, one thing I want to point out that's different with very tough tissues like cartilage and bone, these are the only things that we'll find in cartilage and bone, is that because these tissues are more tough, a lot of times what will happen is like a chondroblast, a little cell, it will make the cartilage. And as it makes the cartilage, it kind of puts it all around itself. And then it is stuck in a hole. Kind of like if you mop your floor, sometimes you mop yourself into the corner and you're like, well, crap, now I'm stuck. So chondroblasts can create cartilage all the way around themselves, and then they're stuck in a hole. And that hole is called a lacuna. And so anytime we're dealing with a tissue that's tough, like cartilage or bone, the cells will be found in lacuna. So a chondroblast is going to make the cartilage, and it creates a little lacuna for itself. And once it is in that lacuna, we now call it a chondrocyte. Okay. So I'm going to walk you through our three kinds of cartilage. The first type of cartilage is called hyaline cartilage. And the term hyaline just means glassy. So this one, you know, under a microscope, this is one of my favorite tissues to look at because it's super pretty. It has this sort of glassy background, this appearance that's really sort of a translucent purpley pink kind of color. And the type of fiber is going to be a collagen fiber, but in reality, you don't really see those fibers. They're sort of blended together. They're not very apparent because the background looks really glassy. Again, we're talking about cartilage, so no longer are we looking at connective tissue proper, which has fibroblasts. Now we're looking at cartilage, which has these chondroblasts or chondrocytes in lacuna. Now I want to point this out. If you notice how they've spelled lacuna here, or how I've spelled lacuna, I added an E on the end. And you'll see this a lot in anatomy. Sometimes when we try to make things plural, if it ends in A, you can't add an S on it to make it plural. Instead, you add an E to the end to make it plural. So this is just plural, lacuna or lacunae. Okay, lacunae is plural. So hyaline cartilage is actually the most abundant cartilage that we have in the body. Where we're going to find it is at the ends of all of our bones in the body. And it's truly there to sort of keep your bones from rubbing on each other as you're moving. It protects the ends of your bones. It absorbs shock. It reduces friction. The other place where we might find this is in an embryo. So in a developing embryo, before bones form, bones in an embryo do not form until about the second month of gestation. And before that, you actually have placeholders made of hyaline cartilage. So we have something called a pre-skeleton in an embryo that's just a cartilage skeleton. that bone will then eventually take over. So this is a great example of hyaline cartilage. We find hyaline cartilage in the sternum, in that bony thorax connecting the ribs to the sternum. So you can see in pink here, that is what we call our costal cartilage. And so if we look at this microscopic picture of hyaline cartilage, it's super pretty. So you can see that the collagen fibers in the back aren't very apparent. It looks kind of purpley, pinky back there. So we don't really see the collagen fibers, but you can see the chondrocytes and lacuna. And notice how those cells look different. So you can see the nuclei of the cell, and notice that it is in this sort of hole. So that's the chondrocyte in the lacuna. And again, that's going to be in any tissue that's really tough, like cartilage or bone. You'll find lacuna. Another type of cartilage is elastic cartilage. This one's really similar to hyaline cartilage, but it has a lot of elastic fibers in it. Remember, elastic fibers are really thin and dark in color. They almost look like hair under the microscope. And they're just like rubber bands. So they're going to provide a different characteristic to elastic cartilage, and it's going to give it a lot more flexibility. So we're going to find this anywhere we need more stretchability. Again, we're still looking with chondrocytes and lacuna because we're talking about cartilage. So where would we find this? This would be in anywhere in the body where you have a little more flexibility, but you still have cartilage. So this right here, your ear, right? Your ear is really flexible. We call that the pinna, and that is cartilage, but the type of cartilage is elastic cartilage. We also have it in places like the epiglottis. Does anybody know what the epiglottis is? Have you heard of that before? It is, you have two tubes in your throat. You have one that carries air, that's called the trachea, and you have one that carries food called the esophagus. Because both of those tubes come up to the back of your throat, it is really important that the correct substance goes down the correct tube, right? Like for example, if you swallow food, the last thing you want is for that food to go down your trachea, to go down your windpipe. We call that aspirating food. People die from that, right? So you have at the top of your trachea, you have a little structure made of elastic cartilage called the epiglottis. And it's a little flap, it's very flexible. And when you swallow, it instantly closes over the trachea. It closes your windpipe. So the only tube that food can go down is the esophagus. So you can try, like if you swallow your spit, notice if you're swallowing, you cannot breathe in at the same time. And that's because of your epiglottis closing over that trachea, okay? So sometimes we call it the guardian of the airways. So here's a picture of elastic cartilage. This is from the pinna, from the ear. And notice when we look at this one, the thing that I think makes this really easy to identify is all of these elastic fibers, right? These little skinny black fibers that look like hairs. Now you know you're dealing with elastic cartilage. And you can see these chondrocytes in lacuna, in those holes. And our last type of cartilage, our third type of cartilage, is called fibrocartilage. This is really similar to hyaline cartilage. It's not quite as thick, not as firm, but it does have nice thick collagen fibers in it. Still chondrocytes in lacuna. We're talking about cartilage. And we're going to find fibrocartilage anywhere where we need to withstand a lot of pressure. So this would be in places like the intervertebral discs. So I'll wheel a skeleton up here. I don't know if y'all can see it, if I pull it up here. But the intervertebral discs are just between the vertebrae here. So all these little discs between the vertebrae, think about how much pressure is on your back a lot of pressure. All of your body weight basically is carried in your back. And so that's a lot of pressure. So that's going to be fibrocartilage in those discs. Also in the knee joint, right? The meniscus of the knee is made of fibrocartilage because of all the pressure from standing. That basically your knees carry the entire weight of your upper body. This is the only time where you're going to see collagen fibers that are pink in color. A lot of times when we look at fibrocartilage under the microscope, the collagen fibers are actually stained a really light blue color. Oops. So that's the only time that I'm aware of that we're going to see something like that. Okay, so collagen fibers here, you can see there are these fibers running around and they're that light blue color. And you can also see really well, you can see these chondrocytes, the nuclei of the chondrocyte in the lacuna, so in that little round space. Okay. So we have gone through connective tissue proper, we have gone through cartilage, now we're going to do bone and then we'll do blood. So bone is, another term for bone is osseous tissue. And bone is different because the matrix inside the bone has been calcified. Anytime a tissue has been calcified, it becomes really hard and rigid. Calcium makes your bone really hard. And so in our bone, we have calcium salts. Now, you know, your bone will store calcium. In reality, our bodies need calcium for every physiological function that's happening in our body. For example, we need calcium for our muscles to contract. Physiologically, we need calcium for nerves to fire. We need calcium for glands to secrete, for cells to be able to divide. We need calcium for everything. So your body will always maintain a certain amount of calcium in your blood. And if there's ever a time where your blood calcium level is elevated, if it's high, your body will take the extra calcium that you have in your blood and store it in your bones. And the benefit of that is it makes your bones even stronger and harder, right? Now, the downside is that if there's ever a time in your life, and ladies, this happens to us when we go through menopause, when we lose the protective effects of estrogen, and we're no longer making estrogen, a lot of times what can happen is our blood calcium level can get low. But remember, we need calcium for everything. So our body goes, I need calcium and I need it fast. So your body's gonna pull that calcium out of your bones. It's gonna leach it from the bones. Now the downside is that it's gonna make your bones more brittle, right? They're gonna be softer because they're gonna have less calcium. And we know that calcium makes your bones hard. So if we lose the calcium out of our bones, it's not great for our bones, but it is a way for us to get the calcium back in our bloodstream so that all of our physiological functions can continue to work. So your body looks at your bones as a place to store calcium. And the benefit is it makes your bones hard. Now the type of cell in our bone is called an osteocyte. We know osteo just means bone. And again, remember, when we're dealing with hard tissues like cartilage and bone, the cells are always found in lacunae. Now, one thing that's really different about our bone is that bone has a fabulous blood supply. It's very vascular. And bone does a great job of supporting your body. It's a framework. It protects vital organs like your brain, your spinal cord, your lungs, your heart. They're all protected by bone. It's also storing things, like I mentioned, like calcium. Other minerals, even fat, can be stored inside our bone. And another big function of your bone is that your bones are actually hollow on the inside. The fact that they're hollow makes it easier for you to lug them around, right? It makes them less heavy, but it also gives your body a place to store things. And typically what we store in the hollow spaces of our bones is red bone marrow. And red bone marrow is where we make our blood cells. So this is a site of hematopoiesis. That term hematopoiesis just means blood cell formation. Okay, so inside our bones, we have red bone marrow, and red bone marrow is where we make our blood cells. That's where we go through hematopoiesis. I think bone is probably one of the easiest connective tissues to identify, bone and blood. Bone, I think, is really easy. If you look at bone under the microscope, to me, it looks like tree rings. So you see the little rings in there. So I'm going to point a couple things out to you. One is this big black circle in the center of those rings. Now this one's not black, but it should be. That big black circle, that is not a cell. That is not an osteocyte. That is a canal for blood vessels to run through. So we call that the central canal. So this is a great example showing you under a microscope how vascular your bone actually is. Has a fabulous blood supply. And then all these little tiny black structures that go around those rings, those are our osteocytes in lacuna. Okay. And then our last connective tissue, so we've done connective tissue propers, we've done our 3 kinds of cartilage, we've done bone, and now our last one is blood. Blood, remember I mentioned this on Monday, it is a very atypical connective tissue. It doesn't really connect or give support. Now, this is what your book says. I would argue that blood is a great connective tissue because it connects everything together. But remember, the reason why we classify blood as a connective tissue is because it develops from the same embryonic tissue as our other connective tissues. Remember, it's that middle layer in that big ball of embryonic cells called mesenchyme. Now, because blood is atypical, it is not going to follow all the same rules of our other connective tissues. Meaning, as we've gone through our connective tissues, I tell you what kind of fiber, what kind of cell, right? In terms of fibers, blood has fibers in it, but you don't see them unless your blood is clotting. So these are soluble proteins that you never even see. And the only time you see them is when you start going through the reaction of blood clotting. The type of cell, again, remember, this is very atypical. So our cell type is basically red and white blood cells. So remember, they don't follow the blast site rule, the immature and mature cell rule. Instead, we have hematopoietic stem cells and then mature blood cells. Okay, so we have blood cells that are found in plasma. All of your blood is found inside vessels. So your blood is not just free in your body, it's always housed in your blood vessels. And the function of your blood is to basically transport gases like oxygen and CO2, transport nutrients, and then get rid of wastes, transport wastes. So this is an image of blood under a microscope. So a couple things I'm going to point out. All the white space that you see is plasma. That's just our liquid that the cells float in. The majority of the cell type that you have in your blood is called red, they're red blood cells. Another term for a red blood cell is, I don't know why my pen's being all crazy. Let's see if I can. Here we go. An erythrocyte is a red blood cell. And then we also have in our blood white blood cells. White blood cells make up less than 1% of your blood volume. The white blood cells are huge. So here are 2 white blood cells. And a lot of times for a white blood cell, I'll just abbreviate it WBC for white blood cell. And we also can call them leukocytes. Okay, so a white blood cell or a leukocyte, or a red blood cell I'll call RBC, or an erythrocyte. Okay. Now this slide is giving you specific names of white blood cells. So we have things like monocytes, neutrophils, lymphocytes. You don't have to know specific white blood cell names. The general name for a white blood cell is a white blood cell or a leukocyte. That's just the very generic terms. Okay. Again, the majority of your blood, about 45% of your blood volume is red blood cells. Remember, these are going to be carrying oxygen. That's their main job. Less than 1% is white blood cells. White blood cells fight infections. So I mentioned to you, I'm going to skip back real quick because I showed you at the start of our connective tissues, I showed you this image. This is an image that is from, I think it's 2 editions removed from your book. I like this image. I walked you through this. I think this is a great study tool. You can see how everything develops from mesenchyme, all the different types of cells depending on the 4 different kinds of connective tissues we're looking at. And then you can see all the subclasses, right? Our 3 kinds of cartilage, our different kinds of connective tissue proper. We've got our bone and our blood. Your new edition for your book, the image is, if you're looking at your book and studying, the image is this one. It's essentially the same thing. It's just less flowcharty. So you can see your 4 kinds of connective tissue here. And then you can see the subclasses for each of those, the type of cells and the matrix. So either one that you want to study from is fine. I think what I don't like about this is that it's left off the whole mesenchyme aspect, right? They all come from mesenchyme. But they're essentially the same thing, those 2 images.